As requested on my last video, I made this one as a tutorial to 3D model cabinet with fasteners. The video will be split in chapters, so you can skip the part you don't need. The cabinet is composed of a bottom board, a left and right side panel, a back board, 2 reinforcements boards and a base. The 3D model is fully parametric. You can adjust the height, the width, the depth, the board thickness, etc. As we build a parametric 3D model, we need to create a spreadsheet to store the variables first. So go in the spreadsheet workbench and create a new sheet. The variables are the width, the depth, the height of the base, the board thickness and the back board thickness. We give them an alias to each, like W for width, D for depth, etc. Then add a standard value for each variable. They would be adjustable at any time. Then go in the Part Design workbench. We will start with the bottom board. Create a new part and a new body. Click on Create a new sketch. Select the XY plan. Select the centered rectangle tool. To add dimensions, press the D key as a shortcut. To access the value of the spreadsheet, we need to type spreadsheet and the alias of the value. In our case, it's the depth of the cabinet, so D. Then we will add the width, which is the width of the cabinet less 2 board thickness, so W less 2 times BT. Close the sketch and choose a pad operation. Put the value of the spreadsheet board thickness BT. Now we will create the groove for the back board. So select the top face and create a new sketch. Choose the rectangle. Select the 2 opposite vertices and the axis, press S to make them symmetrical. Now we will add the dimensions. To avoid any miscalculation of Freecad, we will define the dimensions from the center and the axis. So for the depth, divide by 2 less the thickness of the back board, so D/2, BBT. Next, the dimensions will be D/2, 2 times BBT. So the groove will be the thickness of the backboard. Then add the dimensions of the width, which is W, 2BT divide by 2. Close the sketch and make a pocket hole operation and choose the BT value divide by 2. Then create a sketch on the side face of the board. We will create the holes for the dowels. We create a circle in the center of the face of the board. The diameter is 6 millimeters. Then we will create the circle at the extremity at 32 millimeters from the side and with a space of 70 millimeters. We create a vertical constraint between the circles and make them equal by pressing the E key. Again, we define the value from the center to avoid miscalculation error. Then we create the opposite circles. We select them to make it the same and symmetrical by selection the circle and the axis and pressing S. Close the sketch and make a pocket of 10 mm. Then select the last operation and click on the mirror icon, choose the center plan and apply. Then rename the part by selecting the part and press the F2 key, name it bottom board, do the same for the body. I adjust the value of the pocket because I enter 100 instead of 10. Go back in the spreadsheet and create a new variable. It would be the width of the reinforcement board of the top of the cabinet. We call it small board width with the alias SBW. Add a value of 40 mm. Go back to the part design, we will create the reinforcement top board. So create a part, then a body, then a sketch and select the XY plan. Create a centered rectangle. At the dimensions of the board, which will be the width minus 2 times the board thickness, so W minus 2 times BT. Then add the width with the value of SBW. Close the sketch and make a pad operation of the board thickness value BT. Now select the side face and create a sketch. Select the circle tool. At the dimension to be at the center of the board BT, divide by 2. And 10 mm from the side, so SBW/2 minus 10 mm. Put 6 mm diameter. Then symmetry the circle and make it equal. Close the sketch and make a pocket operation with 10 mm depth. Then select the last operation and make a symmetry operation. Select the center plan and apply. Rename the part and the body by pressing the F2 key and name it small board. Hide the part. Create a new part, new body, and a new sketch on the YZ plan. We will create the left side board. Select the centered rectangle tool. Press D to put the dimension of the height, which will be HT. Then add the depth value of D. Close the sketch and create a pad of a value of the board thickness BT. Select the top face and create a sketch for the groove of the backboard. Select two opposite point and make them symmetrical. Add the dimension of the height, which ht divide by 2. Then add the dimensions for the place of and the width of the groove. D divide by 2 minus 2 time the backboard thickness. So D slash 2 minus 2 time BBT. Then for the width, which will be D slash 2 minus BBT. Close the sketch and make a pocket operation of the thickness board divide by 2. Now select the side face and create a sketch. We will make the holes for the dowels. We will start with the bottom holes. Make a circle on the central axis and add a dimension from the center of the plan of the height divide by 2 minus the thickness of the board divide by 2. Put a diameter of 6 millimeters. Select the circle tool and make the two side circles. Make a horizontal constraint. Make them equal. Now add the dimension for the placement. The extreme vertex will have a dimension of the depth divide by 2 minus 32 millimeters. The other circle has a placement of the depth divide by 2 minus 32 minus 70. Select the circle tool and make two symmetrical circles. Make them equal and symmetrical. Now for the top hole. Select the circle tool and make 4 circles. Make them equal by selecting them and press the E key. Give them a diameter of 6 millimeters. Select the center of each circle and add a horizontal constraint. Now add a dimension to place the height of circle. It's the height divided by 2 less the board thickness divided by 2. Now for the horizontal dimension, it's the depth divided by 2 minus 10 mm for the first circle. For the second, it's the depth divided by 2 minus the width of the small board plus 10. For the third circle, it's the depth divided by 2 minus 2 times the backboard thickness minus 10. For the fourth circle, it's the depth divided by 2 minus 2 times the backboard thickness minus the small board width plus 10. Close the sketch and make a pocket operation of 10 mm. You can rename the part and the body by pressing the F2 key and name it left side board. Now we will create the right side board, which is the symmetry of the left side. You have more than one option for doing this. We will use the scale operator to make it. First select the left side board part and press Ctrl+C to create a copy. Uncheck the spreadsheet. Then Ctrl+V to paste the new part. Rename it right side board by pressing F2. Then go on the part workbench and click on the scale operator. Apply an uniform scaling of -1. It will create a symmetry. Delete the scale 0,1. Create a part and place the scale in it. Right-click on the part and transform it. I made a 90 degrees rotation. I rename it with a proper name. So as to check if the part is still parametric, I adjust the value of the spreadsheet to see if the part change. The part is updated, so everything works as intended. I rename the part and the body to keep a good organization of the file. Now go back in the part design. We will create a new part which will be the backboard. Create a new body and a new sketch. Choose the YZ plan. Create a centered rectangular. Make a dimension of the height, which will be the height minus the board thickness divided by 2, so ht minus bt divided by 2. For the width, it will be the width minus the board thickness, so w minus bt. Close the sketch and make a pad operation of the thickness of the backboard, so bbt. Rename the body with F2 and typing back panel. Hide the back panel. Now we will create the dowel. Create a new part and a new body. Create a new sketch and select the XZ plan. Select the circle tool and make a circle with 6 mm diameter. Close the sketch and make a pad operation of 20 mm. Then apply a fillet operation of 1 mm. Hide the dowel. Now we will create the base of the cabinet. We will start with the front board. First we need to add a new variable in the spreadsheet, the feet deport, with an alias of FD. Create a new part and a new body. Create a sketch in the XZ plan. Make a centered rectangular. The dimension for the width is the thickness of the board, so bt. The dimension for the height is the base height, so bht. Close the sketch and make a pad operation of the length of the width, which is w. Rename the part and the body. Select the side face of the body and create a sketch. We will make the hole for the dowels. Select the circle tool and make one circle. The horizontal position is the thickness of the board divided by 2, so bt divided by 2. Make a diameter of 6 mm. The dimension for the height is the height of the base divided by 2 minus 10, so bht divided by 2 minus 10. Select the circle tool and make a symmetrical circle. Make them symmetrical and equal. Close the sketch and make pocket operation of 10 mm. Now we will create a datum plane for the symmetry. We select the side plan and make a translation of the width divided by 2. Now select the last operation and make a symmetry by selecting the datum plane. Hide the body. Now we will create the side baseboard. So create a new part and a new body. Rename it. Then create a sketch on the XZ plan. Select the centered rectangular tool. Add a dimension for the width of the thickness of the board, so BT. Add a dimension for the height of the base height, BHT. Close the sketch and create a pad operation of the depth minus the feet deport minus the thickness of the board, so D minus FD minus BT. Now select the side face and create a sketch. We will make the holes for the dowel. Select the circle tool and make circle in the axis. Add a 6 mm diameter. Add the height dimension of the base height, divide by 2 minus 10, so BHT divide by 2 minus 10. Create a symmetrical and equal circle. Close the sketch and make a pocket operation of 10 mm. We will now start the assembly. First, make visible all the parts. Then go in the A2 Plus Assembly workbench. Create a new file. Save it and name it kitchen_cabinet_assembly. Now click on Add Shape and import the bottom board and the dowel. I moved the dowel because it was hidden by the bottom board. Be sure that the bottom board has a fixed position on true. Then select the edge of the dowel and the edge of a hole of the bottom board and choose Add Circular Constraint. It will align the dowel with the hole. Select an offset of 10 mm and lock the rotation on true. Select the dowel and duplicate it. You can do multiple copy by pressing the Shift key. I will repeat the same process for the 7 dowels. Now, we will import the right and side panel. We will choose 2 parallels edges, one on the left side panel and one on the bottom board. We add an axis coincident constraint. We will repeat this step with 2 others edges. Now the left panel is placed and can't move. We repeat the same process for the right side panel. Now we duplicate the dowel for the top part and place them like we did for the bottom. Now we will add the back board panel and the reinforcement small boards for the top. We place them like we did for the left and right side panel. Now we will import the side feet board and the front feet board. First we place the side feet like we did for the side board. Then we duplicate 4 dowels and place them. And finally we place the front feet panel. As you can see, we have now a fully parametric cabinet. You can adjust the spreadsheet, saved, and the assembly would be automatically updated. I hope this tutorial has helped you. If you have any questions, please let me know in the comment section. Thanks for watching.